Hey, Joel.
Hey, here, hold on, give me a second, I gotta set up.
Okay.
So I just got home, I had to run back over here.
Oh, sorry.
So, no, that's all right, don't even worry.
Yeah. Um, I'm really jammed up today and tomorrow. I'm trying to fit in all these people. So
Yeah.
it helps me if we can start it now and quit at 6:20.
Okay, that's fine.
Okay. Good. We got through number 2 last time, so we want to start with 3.
Alright, here, hold on. I gotta run downstairs, grab my calculator.
Okay.
I'll be back in 30 seconds.
All right. Okay, cool. Okay.
How's your day so far?
Good. Much better than yesterday. I got hit by flu-like symptoms at about noon, and I was suffering for about till I woke up this morning.
Oh, well.
And I was a lot
Yeah,
better.
I had the flu, beginning of last week, so
Yeah.
not good.
I hadn't had it for a long time. That was a new experience that I don't want to repeat. Okay.
Yeah.
Let's look at number 3.
Alright.
All numbers there, that goes with the number 3, that sentence above it.
Um, so I know that we should probably, one way to do it is to just go through it, um,
That's actually
and
that's the only way to do this one.
do every one.
Yeah, is to back solve it. Just check
Oh.
which one disproves the statement.
Well, the first one we see, 12 divided by 8, doesn't even work. It's a 1.5.
Okay.
So, huh, are we just supposed to find the one that doesn't give us a whole number?
If I made a statement to you saying that all numbers divisible by both 4 and 6 are divisible by 8, could you disprove that statement to me? Because all
Yes.
it takes is one example. Now, notice that B doesn't disprove it because B is both numbers are divisible by 4, 6, and 8.
Right.
Same with E. And the
Right.
problem with C is that C is not divisible by 4 and 6, so we can't use it to disprove it, nor is D. But A disproves it.
Does.
Sure,
Oh.
it's an
Okay.
example of a number that is divisible by both 4 and 6, but not divisible by 8.
Oh, okay. So um, we can't just like get a number that shows the divisibility between 6 and 8 because it also has to be divisible by 4 to prove it.
We need a number that's divisible by both 4 and 6, but not divisible by 8. That's what we're looking for.
Right.
And that would disprove that statement. Okay.
Okay.
What is the area of a trapezoid equal to?
Height divided by
The general
width.
formula. The general formula. Base times height.
Base times height. That's what I meant.
Same as a rectangle, only we need the vertical height, not the slant height.
Right.
We need this vertical height. Okay.
Right.
Then now what? They've given us the area.
Right.
I can fill in 168 for that. What else do we know? If you look at the picture.
That DC is 14 and AB is 14.
So DC is the base. Hold on one second.
Go ahead. You're fine.
Okay, so we fill in what we know, which is the area and the base, and that allows us to solve for height. So what's the height? You have your calculator?
Oh, okay, I get it. So it'd be 168 divided by 14.
Okay.
Height is 12.
Okay. And what's the area of that circle?
The tangent of sides A and B.
Pi r squared.
Oh, I thought you meant like the actual circle. Sorry.
We do. We need the area. That's what they're asking for. What's the area of the circle? So what do we need to know to determine circles? Only one thing. Radius.
Radius.
What's the radius here? If the height is 12.
14.
No. The height would be the diameter of that circle.
So 12.
That's the diameter.
Okay, so the radius would be 6.
Okay, so what's the area of this circle?
$36 pi.
All right.
Let's see.
Most of these problems are two-step problems. In other words, you got to be able to solve the trapezoid and the circle and recognize that the diameter of that circle is the vertical height we just figured out.
All right.
Let's see. No, okay. Now here's one where they give you a figure and there's no note saying figure not drawn to scale, so we can assume that this is drawn to scale.
Right.
Okay.
Wouldn't it be 1/2? So you'd have to figure out which one of these.
This question involves number theory, first of all.
Right.
Not that number theory is hard, you just have to know it to take the ACT or the SAT test. How do I get an even number when I multiply two numbers together? If I multiply even times even, what do I get? Okay. What if I multiply even times odd?
Even.
Okay. And the only other choice is odd times odd.
Which is odd.
Which is odd. Okay. So the probability that the product is even, there's twice as many ways to get even than odd. So if I had to guess right now, I would guess the 2/3 answer, which would be D. Right. But let's, more importantly, let's figure out the odds of getting an odd. Because if we can figure out this one, which we can quite easily, then the odds of this is 1 minus that. That's a key thing about probability. If you have a probability and you can only get two things, in this case we can only get odd or even, and the one that's the easiest to figure out is the odd, then let's figure that out and subtract it from 1, and that'll be our answer. So what's the odds of getting an odd on the first time?
Um,
I'm going to figure out this probability right here. And in order to get two odds, that first one's got to be an odd.
right.
So that would be what?
Would be 3 and 3.
1/2.
1/2.
There's a 1/2 chance that our first spin will land on an odd number.
Right.
It's the chance that our second spin will land on an odd number.
A fourth?
No, still a half. We're not getting rid of anything after the first spin. We're spinning entirely again. So there's still 3 odds and 3 evens. So it's a half on the second spin also. Now, when both things have to occur, you multiply the probabilities together.
Right.
So what are the odds we're going to get 2 odds?
1/4.
Okay. So what are the odds we're going to get an even?
1/4.
Remember, we take the odds of this and we subtract it from 1.
Oh, so 3/4.
3/4 must be the odds of getting an even. In other words,
Okay.
anything that's not an odd is going to be an even. And we just figured out that the odds of getting an odd with both spins, which is what's necessary, is 1/4. So 3/4 has to be the answer. Which answer is 3/4?
The even.
Which answer? A, B, C.
Oh, okay. D.
No.
E.
Yeah. E, you divide top and bottom by 9. You get 3/4.
Okay.
Okay. Oh, I'm not going to be able to blow this one up very big. Let's see. Yeah. No, that's good enough. Yeah. Well, which of the following tables shows a relationship in which A is inversely proportional to B? We got A being inversely proportional to B. Tell me what you know about inverse proportion.
Nothing.
Okay, if something is directly proportional, I would write A is pretty much equal to some constant times B. In other words, if something is directly proportional, as B goes up, A goes up.
Right.
If something is inversely proportional to something else, it's equal to some constant divided by B. As B goes up, A goes down. Okay? So before we go any further, let's just figure out which might be candidates for this. In other words, we might get the answer without doing hardly any math here. Is A a possible answer?
No.
Exactly, because B goes up and then goes down.
Right.
Is B a possible answer?
No.
Maybe. As B goes down, A goes up.
Oh.
That's what inverse proportionality does, but we still have further
okay.
investigation to find out if this is true. How about C?
Yes.
No. As B goes up, A goes up.
Oh, so they have to be opposites.
Right. You have to have them going in different directions.
It doesn't matter if A is the one going up or down?
No,
Or
it really doesn't.
okay.
Okay. Now how about D?
Yes.
That's a possibility. How about E?
No.
Okay, so we have two possibilities, B and D. Okay, so now let's go in and figure out what these mean. Well, if I manipulate, let's get rid of the top one, because that's direct proportionality. But if I wanted to know what this constant was, in order to answer this question, I have to know what's the constant equal to? From the general formula, that constant, which stays the same, it's always A times B no matter which row we're on.
Right.
So which one of these represents the inverse proportional?
B.
Well, what's A pi times B in this row?
1 times 9 is 9.
What's A times B in this row?
8.
It's not inversely proportional then. In other words, this K does not change. It has to be the same no matter what row you're in.
Okay.
So now let's look at D. In row 1, what is A times B?
30.
Row 2?
30.
And row 3.
30, okay.
Makes D the answer.
So no matter what, the K has to stay the same.
Yeah.
For everything.
Yes. Now,
right.
You can get a long ways just knowing that as one goes up, the other has to go down. That would have given us a 50-50 guess here. But to solve it perfectly, you do have to know about this.
Okay.
And same with a direct proportionality. In other words, if I would have said A is directly proportional to B, well, now what is K? K is A over B. So this has to stay the same in every row if the question was about direct proportionality. Okay, and there's really only two kinds, direct and inverse, that you'll get tested on. Now, don't get confused here. Notice that I never memorize this. And the reason is because I want to memorize these two. And if I start memorizing manipulations of this, for instance, it starts getting confusing. In other words, if I solve for K here, I got a lot of stuff that looks the same. This looks a little bit like that. So I'm confusing my memory if I memorize these two. I'm never going to do that. I'm always going to memorize the first two only. Then I can always solve for K if I need to. So that was 6. Okay, number 7.
Okay. Would it be I don't know.
Okay. What's the sign on A? What's the value on A? Give me an approximate value on A.
Negative 1.25.
Give me the approximate value on B.
0.2.
Multiply those two things together. What do you get?
0.25.
Minus 0.25.
Oh, yeah, sorry, yeah.
That's pretty big. So which is the only answer that it could be?
Yeah. No, here, give it to me, Marina. Okay. Sorry, it's my sister.
It's all right.
Sure. It's a little cold.
Thank you. Bye.
Yeah.
Bye.
Bye.
So if our
Close the door. Close the door.
We're kind of conjoined here.
Hurry, please. Oh, come on, please. Thank you. Sorry about that.
It's all right. So if our approximate answer is minus 0.25, and we might
Right.
be off a little bit, but the one thing we know is it's minus, because B is positive and A is negative. So our answer has to be to the left of 0.
Right.
And it also has to be between 0 and negative 1. So there's only one point that could be even close to that. What is it?
B. Oh, sorry. X.
Right.
So it'd be C.
Right.
All right, that makes sense. Yeah.
Okay. Okay, number 8. Couple ways you could do number 8. I'm glad it's on here because it allows us to illustrate a couple of different techniques.
Yeah. Well, we first have to put the 4K over 3 equals 2,000.
No. Imagine you're the supermarket. You buy orange juice for K dollars and you sell it for 4/3 K dollars. So you make a profit on each one.
Right.
How much profit do you make on each one?
Oh, okay. So do we put...
Like I said, you buy it for K and you sell it for 4/3 K. How much profit do you make on each one?
4/3 of whatever you bought it for.
Profit is what you sell it for minus what you bought it for.
Okay.
So what's the profit on each one?
2,000 minus 4K over 3.
Forget the 2,000.
Oh.
Tell me what the profit on each carton of orange juice is.
Four-thirds K.
Minus K.
Oh, minus K.
Subtract your cost.
Right.
This is what they sell it for. This is what they buy it for. So their profit on each carton is what? What's the answer to this?
2,000.
No. That's the profit on all of them.
Oh.
We're looking for a profit on each carton. So what is 4/3 K minus K equal to?
The profit.
If you have 4/3 of an apple and you subtract a whole apple, how many apples do you have left?
A third.
Okay. 1/3.
Oh, okay. Sorry, I was lost. Yeah, okay.
This is the profit on each carton of orange juice.
Right.
So, if that's the profit on each carton of orange juice, then the number of cartons of orange juice times the profit on each carton has to equal $2,000. Right?
Right.
X being the number of cartons that they sell.
Right.
What we're trying to find out. So, in terms of K, and if we look at the answers, there's a K in every answer. We don't solve for X. We solve for X in terms of K. So, solve this equation for X.
So do the...
Solve that
X.
equation for X.
Okay.
What's the first step?
You got to multiply it by a third.
Okay, so now I have, not by a third, you have to multiply both sides by 3 to get rid of this denominator. So now I have x times k equals 6,000.
Right.
So what is x equal to?
6,000 divided by k.
That's the answer.
Okay.
Okay? Now, let's suppose that this is one of those problems where it's actually fairly difficult to formulate it algebraically. So when you find yourself unable, or I'm not sure it's ever the correct way to go, to be honest. Maybe in this problem it was correct to do it algebraically. But there's really another way to do it. Let's talk about it. It's called picking numbers and then back solving. Whenever you see variables in the problem and variables in the answers, consider picking numbers. What would be a nice round number to pick? And I'll show you why we're going to pick 4K. In other words, we can make up anything we want. It won't matter, right? I could say orange juice sells for $2. I could say it sells for $10. I could say you could buy it for $10. Notice that if I say K is 3, that how much do I buy it for and how much do I sell it for? I'm picking K is equal to 3. Read the question.
So $3 each. So you do 3 times 4, which is 12, divided by 3, which is 4. So you'd be selling it for $4.
And buying it for 3.
3.
So in this case, I make $1. Now, the reason I picked a K as 3 is because I wanted this number to be nice and even. I wanted the profit to be a nice round number because how many cartons do I have to sell to make $2,000 if I make $1 on each one?
To make a profit of $2,000, you have to sell 2,000 of them.
Okay. So I know that whatever answer gives me 2,000 when I substitute K equal 3 is my answer. In other words, I made up a scenario where orange juice, you buy it for 3, you sell it for 4. If that were the case, we would have to sell 2,000 cartons to make $2,000. Well, it's not going to matter what number I pick for K. Whatever the answer that I was able to come up with intuitively, and you came up with this intuitively. We didn't go through any math. That's the beauty of picking numbers is that you can figure out what the answer is if you pick nice, easy numbers.
Right.
So when I scan each of these, well, when I divide that by 3, that's not 2,000. When I divide that by 3, it is. That's it.
Mm-hmm.
Now, why did I pick K of 3 instead of 4? Notice that if I'd have picked 4, I'd have been buying it for 4. Then I would have been selling it for 16/3. What's the profit there? Boy, I don't know. It's a fraction. It's going to be hard to do it that way.
Right.
In fact, you would be selling it for 5 1/3, so you'd make 1 1/3. And now how many cartons does it take to make $2,000? That's another hard math problem.
Right.
So there's the art is in picking the numbers. And the reason I picked a number like 3 was because I can tell that if I pick any multiple of 3 for K, it's going to divide out by that 3, and I'm going to have a whole number. So I'm going to be dealing with whole numbers, not fractional numbers. So I could have picked 6. Now watch what happens when we pick 6, just so you get this, because this is a pretty fundamental principle of picking numbers. Let's say I picked a K as 6. So now we're going to buy it for 6. We're going to sell it for 8. So we're going to make a profit of $2. Now how many cartons do I need to sell?
1,000.
So now we go through our answers, and whatever equals 1,000 when I plug in a k equal to 6 is my answer. Again, B,
Right.
when I plug in k as 6, I get 1,000. And it's the only one that I do.
Right.
So it doesn't matter what numbers you pick, except you want to pick numbers that make the math easy to do. Usually, that's the key as far as picking numbers goes.
Okay.
294. 295 next. All right. These are the grid problems, which we haven't done yet, but which we definitely want to do, because this is one place that the other important area, it's different than the ACT. The ACT is 100% multiple choice. This has, I don't know, 10 questions maybe where you have to actually grid in the answer. It's not multiple choice, so you can't use back solving or picking numbers. So on these, we're going to have to do the math.
All right.
Okay.
So we're going to have to actually solve this one out.
Yeah.
I have a question. On these tests,
Uh-huh.
they do give you scratch paper, right?
And they let you use it. I don't know if they give it. You might have to bring it.
No, yeah, as long as we get to use it, because then
For sure.
doing
For
like
sure.
problems like this, I wouldn't be able to do it in my head.
Oh, no, nobody would. So for sure, that's a vital part of it. Okay, so work me through this. Tell me what the next thing I want to write is. And tell me what we're doing here.
For the first one, we're going to solve for D. For the 4C plus 3D equals 37, solve for D. And then whatever that is, we'll replace it for D in the other equation and then solve that out.
Okay, that's definitely one way to go, but I actually think it's a step longer. It's quicker to substitute, because we have this equation already defined completely as one variable.
Yeah.
Let's just substitute this expression wherever we see D. And then we can solve for C. And notice that they want the value of C. So actually it's 2 steps quicker.
Right.
So the next thing I would write would be 4C plus 3 times
C plus 3.
Equals 37. Let's solve this.
Right.
What's the next line?
4C plus 3C plus 9 equals 37.
Next line.
7C plus 9 equals 37.
Okay, you can do those 2 steps at once.
Yeah. And then it'd be 7C equals 28. And then C equals 4.
Okay. Now, we could have done it your first suggestion, but it would have taken exactly 2 steps longer, because we would have first of all solved for D, which we didn't really need. We need C. Once you get D, you can certainly solve for C, easy enough, but every time you can shave a step off, you're helping yourself. So always look at the question, what we're solving for, and realize that, remember when we solve 2 equations and 2 unknowns, we have 2 techniques. One is elimination, the other is substitution. And you use substitution whenever you have one variable entirely solved for by itself already, which you do right here. So this is the reason we would use substitution. What if this said, in other words, if I rearrange this second and write it like this, now to me this is easier solved by elimination, right? I multiply the bottom by 3 every term. subtract the two equations. So I get 7c equals 28, c equals 4. So depending on how the two equations are presented to you is whether you solve them by elimination or substitution. And
Right.
substitution is almost always correct when you have one equation that's already been solved for one of the variables.
Right.
Now, you have any questions on how to grid your answers? When I don't have the instructions on gridding, but the only thing you want to be careful about is if you're putting in this answer, you do not want to put it in like this. You want to put it in as 9/8.
Okay.
Okay, this could be read as 11/8 by the gridding system.
All right.
So far we've only had whole numbers, and those you can't really mess up. In other words, you'd go over to the last digit and write that. All right, number 10.
All right. We would just have to find what 25% of $500 is.
Okay.
Which is $125.
Okay.
So we add that to 500,
Uh-huh.
which is 625.
Right. Now, I don't remember. I don't have this book in front of me, so I can't even look. But I'm not sure if they have a decimal point in their grid. I don't think they do. I think that if you need a decimal point, you have to put it in. In other words, if I wanted to put it in that answer, I'd have to grid it all in. If it's just whole numbers, don't worry about the decimal point.
Okay, yeah. No, yeah, I remember now. It just clicked. I remember now what you were talking about this whole grid thing. It was on the PACT. No, yeah, the PACT.
PSAT, yes.
PSAT, sorry.
Uh-huh.
And it was interesting. It was hard to understand, but in the end, it was pretty easy.
Yes.
Like how to put
The questions tend to be a little easier because it's not multiple choice, so they make the questions a little bit easier.
Yeah.
Whoops. Okay, I guess 11 goes with this triangle here.
Yeah.
Oh, yeah. What does the first sentence mean?
That triangles ABC and JKL look the same because
Similar. They are similar.
Yeah, they're similar because all of the angles are the same.
Okay.
Yeah, we don't know.
Well, what do we know about similar triangles relative to one another? In other words, if I have one triangle here that's 6, 8, 10, and another triangle over here that is similar, same all three angles, and this has an area of 120. Excuse me, if the length of one side is 120, and I can pick any side I want, I'll pick that one. What's the area of JKL?
Using the Pythagorean theorem.
No, you don't want to use the Pythagorean theorem. You want to use the property of similar triangles.
Right, you do. 6, for example, 6 over 10 is equal to x over 120.
Okay, that's one way to do it. You can make the ratio within the triangle, or the better way really is to compare 10 with 120, the same sides. They're both the hypotenuse. How much bigger, what's the scale factor per side of k, this one to this one?
Which two?
What's the scale factor of the triangle on the right to the triangle on the left? How much bigger is it than the triangle on the left?
10 to 120.
Right? 12 to 1.
Right.
So every side of this triangle has to be 12 to 1 over this side. So what would this dimension be?
That'd be 72.
And this dimension down here?
96.
And the area of that triangle?
3,456.
So that's what you would grid in. Now, there's actually multiple answers here, because I could have chosen to let this side be 120. They just said if the length of one side is 120. And actually, they might have truly meant one side. Well, I would let it be that side there. The reason being is because 6 goes into 120 really nicely. Actually, so does 8. But I'm a little concerned about the fact that they said one side of the triangle. I guess that allows me to pick the hypotenuse. But usually when you're talking right triangles and you say the word side, you mean one of these two sides. You don't generally mean the hypotenuse. So for safety measure, it might be safer to pick one of the sides as 120. Now what's the scale factor?
20. 1 to 20.
So what's the bottom side?
Bottom side would be 160.
And what's the area of this triangle?
200. Sorry. Sorry, I was talking about the side. The entire triangle would be 120 times 160. Be 19,200.
Okay. Now when you grid that in there, you do not grid a comma.
Right.
And if there were only 4 spaces for a grid, you'd have had to go back and do the other one, because we got a number that was only 4 digits in length when we first did it. But I do believe there are 5 spaces in the grid, so you'd be able to grid that whole thing in there. Number 12.
All right. Okay.
What's the first thing to do in a word problem?
Write it down, the numbers. Write down the
No.
info we know.
There's always a first step in any word problem. And that first step is very, very important. It'll make word problems a piece of cake. Define your variable and what it means. So we'll let x be the variable, and what's the x going to represent?
5 different numbers.
The first number.
Right.
That's the easiest thing. Not 5 different numbers. That's why you do this. Is because once you write this out, now I can translate this sentence into an equation. If x is the first number, what's the second number? 5 consecutive numbers.
X, Y.
5 consecutive numbers, not letters.
X plus 1.
Okay.
Then X plus 2, X plus 3. x plus 4, and that's it.
That's it. Okay. Now, it's probably important we know that that sum's equal to 500. So can we solve for x?
Yes.
Okay. Speed things up. I'll do it. 5x plus 10 equals 500. Now you pick it up. Tell me what the value of the median of those integers is.
All right. Minus 10, 5. It would be 100.
Solve that.
Say that again, sorry.
Okay, our equation is 5x plus 10 equals 500.
Right.
So solve that. Oh, I see. The answer is 100. Okay. I thought you were solving for x.
Yeah,
No, I didn't hear your x solution. Okay, you're right. The median number is that one right there, which is 100.
Mm-hmm.
Good. Only thing about online is I can't see what you're doing, so that's one reason I kind of need for you to talk out loud when you're thinking through problems, and try not to skip steps because it's harder for me to follow what you're doing. Okay, so the figure above shows the graph of a function, y equal h of x. If function k is defined by k of x, which is h of x over 2 plus 3, what is the value of k of minus 2? Okay, this is a tough one. Let's talk about functions.
Okay.
Y is equal to x squared. No, here, let's see. Y is equal to h of x and k of x. Now hold on, I'm trying to think of how I want to explain this. Let's say h of x is equal to x squared. What is h of 3 equal to?
3 squared.
9. What is h of x squared equal to?
X squared then squared.
Right. In other words, whatever's in the parentheses, we're going to substitute for x, right?
Right.
No matter what it is. So that's the first thing we need to understand.
Right.
Okay. So if k of x is equal to h of x over 2 plus 3, what is the value of k of minus 2? Well, if k of x equals h of x plus over 2 plus 3, tell me what k of minus 2 equals.
It would be h times
Not
minus
times.
2 over 2.
Yeah, it's not times, incidentally. It's of. We're not multiplying these two things here. We're merely talking about a function. So it would be h of minus 2 over 2 plus 3, which is the same as h of negative 1 plus 3. Well, if we want to know what h of negative 1 is from the chart, what is it?
Confused.
Well, look at this chart. That's h of x. So if I say h of minus 1, it means let's find minus 1 on the x-axis and see what the y value is.
So it would be 1.
Right. So h of minus 1 is 1 plus 3. There's our answer.
4. Oh. Okay.
Okay, this was a bit tricky. This was hard. You kind of have to start at the bottom and get it to this point here.
Okay.
And once you get it here, you have to know what that means. In other words, when I say h of minus 1, that means when x is equal to minus 1, what is h of minus 1 equal to? Well, we can look on the chart for that. They haven't told us what this function is, but they've showed it to us on the graph. So it doesn't matter. If they've showed it to us or they give it to us, we can figure out what h of any number is, at least numbers between minus 5 and plus 5, or minus 4 and plus 4.
Right.
Okay.
Okay.
Here's the ponies.
So you just do
Pony
5.
Pony A, B, C, D, and E.
Right.
And here's the people. 1, 2, 3, 4, 5. How many different assignments can we get? How many different people can have pony number A?
5.
Okay, but once somebody has pony number A, now how many different people can have pony number B?
4.
So what's our answer going to be?
5 times 4 times 3 times 2 times 1.
Yep.
$120.
Yeah. Didn't care about the answer as much as long as you knew how to set it up. I'm going to count on you being able to solve arithmetic with that calculator.
Yeah.
So, okay. In the figure above, ABC is isosceles with vertex ACB. So this is the vertex of this isosceles triangle. And points A, C, and D are collinear, meaning they lie on a straight line. What is the value of x? Usually every piece of information they give you is important. Not always, but usually. So we know this isosceles triangle has to be significant.
Right. So if the angle is 50 degrees. Wait. So we know the total angle of of DCB is 100 degrees. Right? Because it says AC.
Yeah, how'd you know that though? How'd you know that?
So 50 times 2.
That's not quite right. That's actually not the correct way to do it. It just accidentally gives you the right answer. First of all, let's start with the information we're given is this is isosceles. What does that mean? Which angle is 50 degrees?
It's A and B.
Okay. So if A and B are each 50, what is this angle right here?
80.
Okay. If this angle is 80, what's both of these equal to?
50.
100. And
100, yeah.
Each one is 50. So the value of x is 50. But this angle DCB is not 100 because 2 times 50 is 100. If I made this number...
Well, the reason I said it was 100 because the angle DC...
Right. You're right. You're actually right. It is. This angle is always the sum of these two angles.
Yeah.
And that's what's 100.
That's what I was trying to...
Okay,
That's what I was thinking.
You were a step ahead of me. You're absolutely
okay.
correct. I was taking an extra step to solve it by figuring out what this angle was. But there is a theorem in geometry that says an alternate or an exterior angle is equal to the sum of the other two, not this one, but the other two.
Right.
All right, this is what I call a symbol problem. You should never miss these. They are not hard, they're easy. You just have to know to substitute. It's just substitution is what it is. In other words, x right arrow y means 2x plus 3y. X left arrow y means 3x plus 2y instead of 2x plus 3y. So if I have 4 arrow 3a, what is that equal to?
Something happened to 4 to equal 3a.
Well, you take the side, the number, you take the quantity that's on the left of the arrow and you substitute it for x. And you take the quantity on the right of the arrow and you substitute it for y. So 4 arrow 3a would be, I'm going to substitute 4 for x, so that's equal to 8 plus, I'm going to substitute 3a for y, so that would be 9a. That's what 4 arrow 3a is equal to, is 8 plus 9a. They want the value of a. Well, I can't solve it yet. But they give me another one. And the other one is 4 left arrow 3a. Well, what's that equal to?
It'd be 12 plus 6a?
Yes. And now this middle equal sign says this is equal to that. So I can now say 8 plus 9a equals 12 plus 6a.
6a, right.
Solve that.
All right. Okay, so minus 6a
Okay.
is 8 plus 3a equals 12. All right, minus 8 on both sides would be 3a. Equals 4. 3 equals 4.
What's the value of a?
Divide by 3. A equals 1.33. 4 to 3.
You might miss it if you grid in 1.3. In fact, you would miss it for sure. You have two choices. You could grid in 1.33 and use all of the spaces, which I guess would be 5. Yeah. You might get this accepted. But that's an incorrect answer, actually, unless you can put a line over that 3. The most exact answer is this. And that's how you want to grid it in, as an improper fraction. Definitely not this way. This will be incorrect on the test. This would definitely be correct. This would probably be incorrect. This might be correct.
Okay. Well, if I need to put it through the decimal, would I put 1.334?
No, I don't think so.
Just to show the continuation?
I don't know. I don't have the instruction sheets on the grid here. It would probably answer that question for you. Next time you get a hold of SAT practice test, look what the instructions are for gridding it before you go take the test, because it'll tell you. It'll tell you what you need to do in that situation. Whether you're supposed to round up or leave it as a repeating decimal, I'm not sure. I don't remember. But I would never answer that with a decimal. I would always answer that 4/3, especially since that was the answer we got. In other words, we got A equals 4/3. Why go any further? There's no need to convert that to a decimal.
Very cool.
Okay.
Did you want to go at 6:20?
Oh, I do. Sorry. Thank you very much. I forgot. And this is a good place to stop because this is a hard problem here.
All right.
Okay, so let's see. Do you, you don't have anything scheduled tomorrow, do you? No, the next appointment I think is with Marina on Monday night, 8 o'clock. I will talk to her then.
All right, cool.
Okay.
No problem. Oh, I have one Saturday.
I'm out of town Thursday through Monday, so you don't have one.
Okay.
I had all of those blocked off. So, oh, that's next week. That's next Saturday you have that one, not this Saturday.
All right, no problem.
Okay? All right.
All right, cool. Well,
We'll talk to you.
Have a good
Thank you. Bye-bye.